Belfast is a modern, vibrant city. New buildings and new roads have helped to create a modern 21st century infrastructure on the surface. Northern Ireland Water set out to modernise the underground infrastructure with the Belfast Sewers project, an ambitious scheme to refurbish and improve the whole of the city's sewage system. But it was clear that the system was no longer big enough to cope with modern demand. Bill Gowdy is head of wastewater procurement for Northern Ireland Water.
Over a number of years, we have noticed that there's been a lot of flooding in Belfast, particularly in the central areas of Belfast, and that's really due to the hydraulic incapacity of the sewers. The sewers simply are no longer big enough to take the amount of flow that's coming in from them. The original option that we decided to go with was this large tunnel through Belfast.
Well, the tunnel was necessary because we had a number of flooding incidents, particularly in this area where we're out at the minute, River Terrace, and also across Still and Park Road and Lower Ravenhill Road. So alleviating flooding is one of the main drivers for the scheme, but it also in fact enhances the environment we're in as well. The River Lagan, in fact, we reduce the pollutant load that goes to it, and also enhances tourism. But it also actually releases some development land for sustainable development in the lower catchment of Belfast.
And that meant that we had to not only select the route to avoid certain buildings, we tried in most parts to keep the route under public roads, and that would avoid any damage to property. So there was a lot of route selection. We also had to look at services, we had to look at land properties and values and see where we could put various shafts. We had to liaise with many stakeholders, and we had to look at the geology, in fact, of Belfast, and that certainly was one of the most challenging aspects.
Well, this scheme actually started in November 2006, but there was probably a good 10 years' work before that.
Well, one of the major parties we'd been talking to was the Environment and Heritage Service, or now Northern Ireland Environment Agency, because there are a lot of issues to do with the spills that we have from our sewer network into the watercourses, so they were particularly concerned about water quality. But there were also issues that a job like this creates a lot of waste material, spoil, and how we manage the disposal of that. And most particularly, we were fortunate that we were able to use most of the tunnel spoil for capping the landfill site at Dargan Road.
Not only getting the approvals in place for the funding, which was significant, but also appointing initially a team of project managers. Atkins, in this case, through open tender, they won the bid and they appointed their own project team.
Atkins are actually one of the leading consultants in this particular field. We are a very large consultancy, and we bring all of the professional attributes that are necessary to deliver a project of this nature.
The project itself was probably around about £100 million whenever we first planned it to be done, and therefore it did attract an international audience, of course, from contractors. It's a large diameter tunnel, it requires certain expertise to do that, and we did have quite a number of well-known international companies and of course local companies joining together in joint ventures to undertake this project.
We procured the contract. Morgan Est and Farrans were the JV that were appointed. So since that time we have been responsible for the planning of the work, and there was over a year's planning went into this particular project in order to prepare for the contract documentation and the procurement of the contract. The contract is a partnering contract, which in itself involves engagement at all levels. So, my role can be looked upon almost as facilitating the process, and to always bring to bear a balance and reasonableness, which we have to do under the contract, to ensure that the contractor is dealt with fairly. And we also look after the interests, of course, of our client, Northern Ireland Water.
Given the scale of the project in hand, a strong integrated team bringing a vast range of skills and experience together was essential. Morgan Est, one of the UK's leading tunnelling specialists, joined with Farrans, one of Northern Ireland's leading and most experienced civil engineering contractors, to create a joint venture to carry out the works on the project. Paul Ronicle from Morgan Est was the project manager, and John McReynolds from Farrans was his deputy.
We would have been imprudent, I think, to come here without a local partner. Apart from the specialisms in civil engineering that Farrans offer us, they have a very good local knowledge, obviously, because they've worked here for a long time.
I think it's something that, as two separate companies, we've been looking at for quite a while before the project was awarded, and it made a lot of sense to form a fully integrated joint venture which would take account of the specialisms of both companies. From the Morgan side, the specialisms of the tunnelling and underground works, and from the Farrans side would take account of our own local knowledge and specialisms in heavy civil engineering.
There's always a gestation period for a joint venture because you always come from different cultures and different specialisations. I think here it worked very well because all the central functions like purchasing and engineering control and programming were very much an integrated team, and I think it took a while for us to come together as a fully integrated team, but I think an outsider coming in now, apart from our accents, wouldn't recognise the difference between the Morgan people and the Farrans people. We work as one entity.
The tunnel stretches for almost 10 kilometres at an average depth of 30 metres below ground. There are 19 access shafts along its length, and the shafts take the storm overflows from the sewers and act as extra storage capacity for the system. They range from 10 metres to 37 metres in diameter and to a depth of 40 metres at the deepest point. Looked at on the map, the tunnel is an inverted Y shape. Starting at Glenmackin Street and Park Road, two smaller tunnels join in Crummock Street, where the 4-metre tunnel takes the flow down to the terminal pumping station in Duncrew Street. This is by far the largest tunnelling project to be undertaken in Ireland, and the team were aware of the potential for major disruption to the citizens of Belfast.
This is a major project going through a city centre, and therefore we've had to take account really of customer needs in this, and of course traffic disruption would be one of the major components that we'd have to consider. Now we have liaised quite intensely with road service to make sure that any disruption we cause is kept to a minimum. But in addition to that, we've also gone out and spoken to customers, to people who may be affected by our project, and explained to them what we're doing, and indeed in many cases accommodated their needs.
We do a lot of work within residential areas. That could have been an issue with some of the local residents. We put in a lot of effort. We organised public meetings. We invited the local residents who would be affected by the works, and I think the effort that was put in at an early stage has paid dividends then throughout the works.
So before work starts in each new location, my role would be to go and identify who the key community groups or residents groups are in each area. We would facilitate then a meeting with members of the project team to go along and introduce the project, explain exactly what the work's about, what the benefits for the local community will be, and then get some feedback from them as to what they believe the issues might be for their local community.
I think it's very important that the public know what's going on in the project, because this is such a major project, and they can see it's going to affect their daily lives if they're travelling to work, if they need to really know if something's going on, if we're closing a lane or there's going to be a bit of traffic build up. For example, we did a lot of work on the Dublin Road recently, so it's really informing people what's going on. And
we keep regular contact. I think the key thing for our role is that, as well as introducing ourselves at the outset of the work, that we maintain communication right throughout the project. So we would go back and we would have regular updates, even if it's only a telephone call to check in, how's things going, is everything all right. Let them know when a next stage of work is maybe going to change, if there are any change in working practices going to be, and let them see that we are there and committed to working and listening to them.
This is such a major investment, and it's not just, an inconvenience. It's, trying to explain to people what exactly we're doing, and it's going to benefit the people of the Belfast area and help reduce flooding. So really just highlighting what's going on and why we are closing roads and how keeping them informed of how the project's going.
Work on site got underway in January 2007. A Minister of State in the Northern Ireland office performed the opening ceremony, and the men and machines rolled into action. But there's more to constructing a shaft than digging a hole in the ground, and ground conditions were not easy. In particular, a layer of wet, unstable ground, well known to engineers in Belfast, presented its own challenge. Jim Walby was in charge of shaft construction.
What people throughout the Belfast area know as the Belfast Sleech, which has generally underlying it some very wet sands and gravels. And usually throughout this contract we'll find that that is sandwiched with some very stiff boulder clay and then sands and gravels leading down onto sandstone. We've introduced a dewatering program, which means we've drilled down from geotechnical assessments and established the depth of borehole to be able to draw water down and relieve the water pressure on the bottom of the shaft.
The shafts were constructed by initially sinking a circular retaining wall. The earth inside this retaining wall was excavated, and a steel cutting edge was set up and attached to the first shaft segment. Hydraulic rams are installed and the segment is jacked into the ground. The bottom of the shaft is excavated, the next segment is added, and the rams drive the whole construction further into the ground. With further excavation and more segments added, the required depth is achieved.
To be able to complete the shaft successfully, we have the dewatering program taking the pressure off the bottom of the shaft, but at the higher levels, to be able to mine through that ground, we have to use the kind of equipment directly behind me, hydraulic grabs, working down through between 2 to 17 to 18 metres depth of water. At the present, the ground that these machines are digging down through means we have 1,870 tonnes of water sat on the ground. The ground when it comes up looks very stiff, but you take the water pressure off and that ground becomes very mobile, very soft sands. So we have to maintain this water pressure on the sands until we're down into a very stiff clay, when we can then stop and pump out the water, and then we can start mining the rest of the excavation in very stiff clays. This kind of construction is called caisson sinking. It gives us a safer environment that men can build the concrete sections on the surface without having to enter the shaft, and they're always building them in front of them. And secondly, by actually jacking them down into the ground, in the dry condition, it gives us the benefit that the steel cutting edge is offering protection at all times, 1 metre to 1.5 metres below where the men are, and therefore no man is exposed to ground being able to come at him no matter what the circumstances are.
With 19 shafts being built, it was inevitable that there would be some interesting history coming out of the ground. Here we can see the original wooden piles that were sunk for the construction of the Belfast docks in the 18th century being removed at a shaft beside the Harbour Commissioner's building. Completion of shaft 11 allowed the engineers to lower the first tunnel boring machine, or TBM, into the shaft to be assembled in situ and for tunnelling to begin. The various parts of the TBM are lowered into the shaft onto a specially constructed cradle. When it is complete, it is 70 metres long and stretches from the huge cutting head at the front to a conveyor system for extracting spoil at the rear. Richard Merriman was in charge of tunnelling.
The machines themselves are very special. The two that we had here are very alike, they're just different in size. They're about 70 metres from the very front to the very back of the machines. You've got 8 men looking after each machine, that's right from operator, mechanic, electrician through to engineers. There's a cutter head at the front, which is very much like a giant drill bit really. It's 4.5 metres in diameter. It rotates in either direction and actually excavates the ground, and as the machine advances through, it builds a precast concrete lining as it advances. They work very much in a method of maximising production but limiting the effect of the ground above them, so minimal settlement but maximum production. We have at best done here about 36 metres advance in a 24-hour day. The machine is serviced by trains. We've got 8-man crew on the machine, but at any one time you could have 3 locos or 3 trains in the tunnel. And basically the way it works is that the machine takes the precast concrete segments in, which supplies the machine with a concrete lining, and then the excavated material comes out in muck skips. Shaft 7, which is behind us here, to maintain production here during the day and night, we've put in an acoustic shed because of the built-up area that we're in the middle of Belfast. And then within the shed, you've got what we call a high-angle conveyor, or shortened to hack, which in effect lifts the excavated material from 30 metres down, brings it up vertically, and puts it onto a horizontal conveyor out here in the yard. At the other sites, it's tipped into a muck skip, and the muck skips are individually hoisted and tipped on the surface. Belfast's been challenging for everybody. We've had everything from rock and the sandstone in Belfast. We've had clay, we've had running sand, and unfortunately recently we went through about 800 metres of contaminated ground as a result of an old gasworks development here in Belfast back in the 1970s.
The Terminal Pumping Station, or TPS, would be the largest pumping station in Northern Ireland and a crucial element in the modernising of Belfast's sewage system. It will reduce the strain on sewers across the city by pumping stormwater to either the Duncrew wastewater treatment works or to storm screens for treatment and discharge into the Herdman Channel. At 38 metres in diameter and 40 metres deep, the TPS will have the capacity to hold 4 million gallons of wastewater, equivalent to 7 Olympic swimming pools. The sheer size of it would call for the use of specialist construction techniques. Kevin Crilly is the engineer in charge of construction.
Because the job is so unique, everything is more or less new. Some of the techniques we've used in this project have been new to us, and it's been a learning curve. We had to do the initial excavation using a diaphragm wall method. The diaphragm wall method was chosen basically because of the depth of the wall we had to go down through the notorious Belfast leach, and it's because of the size of the actual structure we had to build. The diaphragm wall system basically works in that you excavate small sections of a wall in sections. You excavate using cranes down through the sleech, and you create a vertical void, and in which you put bentonite to keep the sides of the excavation out, and then you pour reinforced concrete into it. You do this in a series of straights which all connect together, and then once you excavate, then that creates a wall around the side of the structure. After that wall was in, then we excavated. The wall allowed us to excavate down through the sleech into more competent ground, sandstone below. And basically once the wall was in, then we just excavated down to this level. And from there on, we excavated down, and then we used a spray concrete technique to spray the walls of the structure from there on down.
Just over a year after the project started, on the 24th of April 2008, the 4-metre tunnel broke through to the TPS. But not everything went smoothly. As in every project, there were problems to be overcome. Alan Skates.
We have experienced, a number of significant problems in the ground during the course of the work, which have really been challenging the skills and expertise of the project team.
The original site investigation showed a very limited amount of contamination adjacent to River Terrace, but when we proceeded to tunnel through that section of the works, we found the groundwater was heavily contaminated with coal tar, and that manifested itself as benzene within the tunnel environment. And in fact, we had to put all the guys into full biological suits with filtered air to protect them from the benzene.
The contaminated ground, we overcame that and were able to continue mining, bringing in special methods and procedures. The very basics of limited working hours, monitoring the actual contaminant levels, putting in respiratory protective equipment as well as personal protective equipment, so chemical suits, carbon filter breathing masks, gloves, Wellington boots, all that was resistant to the contaminant that we were mining in.
We worked closely both with specialist advisors and with the HSE Northern Ireland to be sure that everybody was happy that we weren't exposing the workers to any risk.
Balmo Park, a particular problem again. Belfast is covered by what we call boulder clay, which is a glacial till material that, although it's a clay, it's actually got within it various what we call boulders, which are rocks which have been laid down by glaciers, and these have been mixed in with the clay, And they come in all sizes. I mean, you can get something as small as my fist, or you can get something the size of, a car.
The least risk option for that would have been open cut, and we worked in conjunction with Atkins to redesign the tunnels so that a large proportion was slightly shallower than the original design. But it was clear that although Belfast City Council didn't have a problem with us working in the park, Ormo Golf Club had a problem with us open cutting across the golf course, and so we took the decision to go by tunnel.
The contractor has been in the park now for quite a number of months and has been working steadily through the form of technique he's using is pipejacking, and the pipejacking is a steady, progressive way of boring through the ground, and the problem of the boulders certainly is there. We have experienced it, but we have dealt with it, and the contractor is successfully achieving it.
At the TPS, the fit-out work is underway, and the new outfall to discharge treated stormwater into the